Good evening, everybody, and welcome to tonight's episode of Whether or Not. I'm your co-host, Dan Guzman.
And I'm Allison Gutleber.
So, Allison, recently we've had a few days with temperatures right around average and just a few days that were a little wet.
Yes, but we will see those temperatures rising towards the end of the week, but Joe will have that up in his forecast.
Yes, and also in tonight's episode, we will have some nature in the news stories. I will have a story on deadlier heat waves for the East Coast and another on a new discovery to help better understand El Nino.
And I will be talking about Australia's Great Barrier Reef and how the Atlantic Ocean is as hot as it's been in 2,900 years. But Nick has a feature on fire weather as well.
But first, here's nature in the news.
The Atlantic Ocean is at its hottest in 2,900 years. The ocean had absorbed over 93% of excess heat from greenhouse gas emissions over the years. In the past decade, the ocean has been the warmest ever in nearly 3 full millennia. The new discovery about the Atlantic Ocean came from a mix of ice and sediment cores, as well as thermometer data. Scientists were able to analyze titanium in the layer of sediment in order to create a time series for the past 2,900 years of the Atlantic Ocean temperatures. Data shows the wave pattern of warm and cool periods extending into the past, including a big dip in the Little Ice Age that ran from 1300 until 1600. Since then, it's been rising steadily up, with a sharp peak in the last few decades. With the oceanic temperatures rising and falling in patterns over decades, the recent spikes in the temperature are beyond normal. The rising temperatures have been linked to severe hurricanes and can mean an even more harsh storm season for our future.
With our ever-changing climate, heat waves are expected to increase along the East Coast. This is very dangerous for places that are already vulnerable, like Newark, New Jersey. People who live in urban areas of the Garden State have nothing but concrete and asphalt making up much or all of the ground. This, in addition to greenhouse gases trapping in more heat, have caused the annual temperature of New Jersey to increase by 3.5 degrees Fahrenheit since 1895. Scientists warned that by 2050, this increase could nearly double. Unfortunately, the rapid warming is also expected to greatly increase the amount of heat-related deaths, which is currently about 12,000 people annually across the country. One way New Jersey is fighting this is by having more green spaces filled with trees and other plants to help cool certain areas. Other efforts include plans to distribute air conditioners to low-income elderly residents and ensuring that some public apartment buildings all have AC units installed as well. While these efforts will help that state, the entire country must help to fight the heating effects of climate change.
The world's largest coral reef, the Great Barrier Reef, located in Australia, covers nearly 133,000 square miles and is home to more than 1,500 species of fish and 411 species of coral. Since the 1990s, the reef has lost 50% of its coral populations, with climate change as a main cause of reef disturbance. In the past 5 years, mass bleaching events have caused harm to the reef. Our record-breaking temperatures in early 2020 triggered more harm to the reef because although bleaching alone does not kill the coral immediately, when temperatures remain high, eventually the coral will die. This will destroy a natural habitat for many species of marine life, as reefs are fundamental to the health of marine ecosystems.
A new discovery by scientists at the University of Arkansas has established a link between the Amazon climate patterns and tree ring chronology from the Amazon basin. By comparing tree rings from areas in the Amazon and others from farther south, they've noticed an inverse relationship between the tree growth and therefore precipitation patterns. Drought in South America is correlated with wetness in the United States and Mexico. The underlying phenomenon causing this alternating pattern is known as El Nino, which brings unusually warm water in the Pacific Ocean. Tree rings from the past 40 years have also indicated increased flood and drought extremes. This leaves scientists interested to find out if it is directly caused by human-induced climate change and deforestation.
I'm Joe Rook here with your Central PA forecast. It was a rather wet week, and things will stay wet throughout the early half of our weekend, lightening up as we head into Saturday and Sunday. So taking a look at our current setup, a cold front is stationed in Central PA. As we do head throughout the day Friday, precipitation may increase in intensity by the afternoon, quickly clearing though as we do head overnight. As we head to Saturday now, that front and low pressure system will be over New England. So what that means for us, the rain will end by Saturday morning. There could even be some snow in high elevations, but quickly clearing. Sun will be out shining. Temperatures heat up for Saturday, and then Sunday high pressure comes and dominates the region. Sun will be out in full force. This will be a crisp fall day. If you're out and about, this will be the day to be out. So Friday we can expect temperatures of 55 degrees and some showers, which will linger as we do continue throughout the overnight hours, with that low dipping down into the upper 30s and a thick cloud cover, so we'll trap in some of that moisture. Will be a muggy day, but then as we do head into Saturday, 54 degrees, sun out in full force. As I did mention early in the overnight hours, there could be a passing shower or even snow shower in the higher elevations, but the rest of the day will be beautiful. A nice fall day with that 54 degrees, so slightly below average, and that below average temperature will carry over into Sunday, but we will manage to heat up to 59 degrees. Few clouds in the sky, but the sun will be out and shining. This will be a crisp fall day, so be sure to get out and enjoy it. And now I'll send it over to Nick, who has a feature on fire weather.
Fire-induced thunderstorms towering over cities, raging fire whirls dancing across landscapes. Wildfires don't just incinerate thousands of acres, they can also produce their own weather. These phenomena make fires more dangerous and grasp the attention of the public. But many do not know a lot about these forces of nature. Wildfires emit so much heat that they can cause clouds to develop and even create thunderstorms. Typically, the clouds produced by wildfires are pyrocumulus and pyrocumulonimbus.
So pyrocumulonimbus clouds are associated with very large wildfires, and they differ from your generic pyroQ. You can have a very small fire that generates a small cumulus cloud on top of the smoke plume. And those are fairly benign, like any fair weather cumulus. But cumulonimbus, obviously, is a thunderstorm and a severe weather event, and they're not as common on wildfires.
For a pyrocumulonimbus cloud to form, there needs to be instability in the atmosphere. This comes from mid-level moisture and the heat released from the wildfires, which forces the air to rise vertically. As the air rises, water vapor condenses and forms into water droplets, which leads to the formation of a cloud. Pyrocumulonimbus clouds reach high into the atmosphere and have ice crystals in them that collide due to the upward motions. Electrical charges result from the collisions, and eventually the built-up charge gets released as lightning. As with any thunderstorm, there are hazards, but fire-induced ones bring extra threats with them. Lightning is of course present with thunderstorms and can possibly spark new fires from the strikes that contact the ground. Pyrocumulonimbus clouds can produce rain, which evaporates into the air and cools it. This results in strong winds accelerating downward, which is known as a downdraft. Downdrafts can push fire fronts in the opposite direction, which makes it dangerous for anyone in the fire's path. Embers from fires can also be carried tens of kilometers away by these strong winds and can result in new fires forming. This is known as spotting. Downdrafts are also very damaging and have the potential to contain winds of over 100 miles per hour. As if fires producing thunderstorms weren't bad enough, fire whirls and fire tornadoes can also develop from fires.
Fire tornadoes or fire whirls. So we try to distinct in the fire behavior community the difference between a fire tornado, which is really something that's been generated by a pyrocumulonimbus, versus your everyday fire whirl. Fire whirls happen all the time. They're just about every fire will have a fire whirl. So when you see, the media saying, "Oh, there's a fire whirl in this fire," it's like, yeah, of course there is, because how do dust devils form? And maybe but you got horizontal wind shear, you have vertical motion from the heat, and so you can tilt ambient vorticity into the vertical, and that happens all the time on different parts of the fire lines.
Typically, fire whirls only last a few minutes and are on average a couple hundred feet tall. Fire whirls usually have winds of 30 to 40 miles per hour, but can be very destructive with their fast forward speed and their ability to rapidly spread fire. Fire tornadoes are extremely rare and get rated on the EF scale, unlike fire whirls. Most fire tornadoes have been rated an EF0 to an EF1, with winds upwards of 110 miles per hour. In 2018, the Carr Fire produced a fire tornado that was the strongest in recorded history and was rated an EF3 with winds of 143 miles per hour. Dr. Craig Clements was one of the meteorologists to survey the fire tornado's damage.
California has now the record of fire tornadoes with the Carr Fire, which was an EF3. And my team of students and I were invited by the Forest Service to go do an initial field analysis damage survey of that. And the things that we saw, you may have seen the picture of the pipe wrapped around the tree. It was a gas line that was wrapped around a tree. All the bark on the trees were scoured and removed from sandblasting, and just major power lines dropped down. So they estimate that as an EF3.
On August 15, 2020, the first ever fire tornado warning was issued by the National Weather Service for a fire tornado produced by the Loyalton Fire. This fire tornado was rated an EF1. Over the years, researchers have obtained a solid understanding of pyrocumulonimbus clouds, but still know very little about fire whirls and fire tornadoes. Part of this is due to the lack of resources made available to them. Hurricane specialists have recon planes to gather data, and severe weather specialists have mobile radar networks. Fire weather specialists only have a Doppler radar and LiDAR. New technology is coming out soon, so fire weather researchers like Dr. Clements are excited to gain a better understanding of these extreme fire phenomena. For Whether or Not, I'm Nick Guzzo.
I'm Joe Ruch, back again for your extended forecast, but before we take a look into the future, let's break down once again what will happen this weekend. Some wet weather expected Friday, tapering off through the overnight hours into Saturday, where the sun will come out and shine for the remainder of the day, and that sun carries over into Sunday, so a beautiful core of our weekend really, once we get over some of that rain on Friday. But now going ahead next week, you can see those dry conditions are going to really dominate, with the only threat coming midweek when a front will pass through. That front will also introduce below average temperatures, as you can see on this graph. So Monday and Tuesday, a few degrees below average, nothing out of the ordinary. Fall is in the air with that, but then we get into Wednesday and Thursday when the cold front passes through. We're going to talk temperatures in the mid 50s, so it will be a bit chilly if you do happen to be out and about. But then as we head into your start of next weekend on Friday, temperatures heat back up, sun will be out and shining, so a beautiful start to your weekend next week. That's all I have for today. Dan and Allison, back to you in the studio.
And back to our Weather Whiz Quiz question. About how many degrees Fahrenheit has New Jersey's annual temperature risen since 1895? Is it A, 3.5, B, 6.3, C, 5.3, or D, 1.4? And the answer is A, 3.5.
Yes, 3.5 degrees has been the annual increase in temperature for New Jersey, and the amount of heat waves are expected to increase. So by 2050, that increase in temperature could be double. So we really need to be careful and be taking care of ourselves in hot days.
And we especially need to take care of the elderly, who are the most vulnerable group. So we have to make sure not only to care for ourselves, but each other, as Dan just said.
Yes, and that's all the time we have for tonight's episode. I'm your co-host, Dan Guzman.
And I'm Allison Gutleber. Have a great evening.